Okay, so here is a variation again from Netflix. Again, this is a technical blog where they talk about what artwork they use for a video. For example, imagine there is a movie like this. I think this movie is called The Short Game. This is the default art, or this is the default image that is shown. And they said, hey, what if we create a new image? Look at this. They're trying to showcase some new show that they have, a Netflix original show that they have. This is the default image given by some of their artists, but their artists also gave different images. So this is called the artwork for a video, right? This is like your poster sorts. Now, which artwork or poster generates more clicks? This is important, right? Because the purpose of artwork is to make you curious and click on it. This obviously, there is somebody who is doing some, seems like a small boy who is doing some golf, so more interesting it looks like. Now there are two variations here. I'll come to more variations in a few minutes. This is also called as a thumbnail, right? Yeah, somebody just pointed that. Yes, this is the thumbnail of sorts, right? So the question here is, how do I determine, again, this is a slight variation, okay? How do I determine if the new variation, this is your default, right? Like this is your control and this will be your treatment. Will the new artwork or the new thumbnail generate more clicks? Very simple experiment. How do we do this? Again, without going too deep into it, what we are measuring here is this. First, we want to say whether something is control or treatment. Control basically means the default. The treatment is basically the new one, right? So in control and treatment, what we are measuring here is a binary variable, not any numerical variable. That's why I said this is different. 1 here, let's assume, means click. 0 means no click, right? So you have control, you have treatment. Let's assume you have n values of control, m values of treatment, just like our previous setup. But here what you have are just binary values, nothing more. Okay. And this you just ran a simple test. Now you want to determine if, again, you want to employ permutation test here and say, hey, is control better or treatment better? Okay. So how do we do that? Again, remember here the numbers here are not, that's the key part here. The numbers that you have here are not real values. They're only binary, 0 or 1. Okay. They can also have multiple values. The same strategies will work. But let's look at this actual scenario. So in this case, we'll again do permutation sampling, a permutation resample test. Our test statistic we have to design very carefully. Our test statistic will be click-through rate. So what is click-through rate? It is basically number of clicks divided by total number of views. Right? Click-through rate is this. Right? So imagine we have these two. For example, let's assume I have the default, which is in control, and I have the new one, which is there in treatment. In treatment, let's assume I showed this to some 1,000 people, of which 200 people clicked. In the control, let's assume I also showed it to some 1,000 people, of which some 180 people clicked. Now, by just looking at this, I can't come to the conclusion because the difference of 20 here could just be because of my sample sizes being small, being just 1,000, right? So can I be very confident that yes, this new artwork or the new thumbnail is better than the default one? How do I do that? Very simple. The strategy here is very simple. Okay. Slightly different from the previous problem. All we do here is we take this column. Again, there are n values here, m values, right? We take this column. We shuffle this column. Look at this. Again, same strategy. So given the original data, we'll say what is the CTR of control and the CTR of treatment, click-through rate, right? We take the difference between them. Okay. Then we shuffle these values. Again, we can permute these values, right? These ones and zeros we can permute, right? So again, do the same thing. You permute them. Every time you permute, right? Every time you permute, you don't have to resample again because the first n values will correspond to control. The next m values will correspond to treatment. So you permute, right? You're doing permutation. Again, when you permute, all the numbers will change. Then you compute the CTRs of all the first n values and these values. By permuting, you're saying, what if everything is jumbled up? Okay, if everything is jumbled up, then what happens, right? If these values are completely jumbled up, what will be the difference in my CTRs? right? So the idea is very simple. You have your test statistic, which is the observed, let's say you have the observed difference in CTRs. Okay. Then you permute, compare. So you permute and compare, then you get the difference in CTR. So CTR difference 1, 2, 3. You keep repeating this exercise k times, just like the previous one. Now look at these distributions and see where does this observed difference in CTR fall, just like the previous exercise. The concept stays the same. The only slight difference here, right? The only slight difference here is how we are jumbling it up. In the earlier case, we jumbled up. Again, the idea is the same. The fundamental difference here is what we have here are binary values, ones and zeros. It all boils down to the fact that we jumble or we shuffle all these values and the test statistic that we use. Everything else more or less stays the same and everything will work reasonably well. That's the key idea. Okay, now comes a tricky question. What if instead of 2 alternatives, what if I have 9 alternatives? This is actually from an actual experiment that Netflix created. So I think they have a Netflix series called Stranger Things. And these are 9 thumbnails or 9 artwork which are there. And they have to experiment with all of them. Just imagine, for each of them, even if you send 5% of your users to each of them, to this ad you show 5% of users, then you send 5% to this, then you send 5% to this, you keep sending 5%. There is a big problem that you'll run into, which is if you're doing A/B tests, right? So in this case, what do you have? You have a control. Okay, let me just write this down. You have a control where you have some default artwork, right? And then you have multiple treatments, treatment 1, treatment 2, so on and so forth, treatment 9. In this, I'm going to show artwork 1, artwork 2, so on and so forth, artwork 9, right? And then I compute what is the CTRs, what are the click-through rates in each of these. I'll compute them, right? And using statistical test, I can conclude. But the problem here is, even if I allocate 5% of traffic to each of these 9 variations, 45% of my data, look at this, how many treatments I have. This is very important. My control is lower risk. I have 9 treatments. 9 treatments basically means 45% of my data is being assigned to treatments. And these treatments can be risky. They can be very, very risky, right? So the biggest concern that I have here is, while I can do this experiment, spending 45% of my user traffic to something that has not been tested, not tested rigorously, is extremely dangerous, right? So what do we do in such a case? There is a solution. That solution is called multi-arm bandits. This is the standard solution that's used across the industry for doing large-scale A/B tests. When there are multiple things, 9 things or 10 things or 20 things or 100 things to test, right? This is very, very common problem. We'll try and discuss this by the end of today's sessions, right? Hopefully in session 4, if time permits.